All right, now let's take a look at this question. We're continuing with volume, which we started off last week. You recall last week what we did? So last week, what we did was we completed volume as well, right? Except that we were doing volume of solids, cubes, and cuboids, as well as visualizing the cube from the different views and packing of the cubes. So packing of the cubes is where we have a container and we try to pack the cubes into the container. So today we're doing a continuation of last week, but still on volume. Okay, we're still on volume. All right, no worries, Jeremy, thank you. Okay, so we're still on volume. So we're going to talk about the common height. Okay, now when we talk about volume, okay, so we have cuboid. Okay, so we have a cuboid here. So to find the volume of the cuboid is the same as length times breadth times height. Okay, length times breadth times height. Now, together, length times breadth make up the base area. We can also say volume is equals to base area times height. Now, when we say that we have a common height, okay, so we went through last week where you have a common height between two containers. What you do is you let the height be 1 unit, or if some of you are familiar, let the common height be x. Okay, so we'll take a look at some of those type of questions. So then we know that from the base area, to find the base area, given the volume, will be volume divided by height will give you the base area. So the volume formula itself, you can rearrange such that it allows you to use the formula to find any of the dimensions that you need. Okay, so now we have a cube. So all cube has how many faces? How many faces does a cube have? Just like a cuboid, how many faces does a cuboid have? Thank you, Yashika. So 6 faces. Okay, how many edges does a cube have? How many equal edges? Anyone? How many edges? Ooh. Do you know what we mean by edges? Dimension 3. So Jeremy says 3. Anybody? How many edges does a cube have? Anyone? No? Okay. Now, everyone look at the screen. Now, I'm going to show you what edges mean. So this is an edge. 1, 2, 3, 4, 5, 6, 7, 8, 9. Behind 10, 11, 12 edges. Okay, so a cube has 12 edges, 6 faces. So a cube has 6 equal faces, 12 equal edges. Okay, now, so we went through last week. If let's say you have a tank which is completely filled with water. Now, when it comes to volume question, okay, now before I continue with this part here, let me you see these cubes that I have here? Can you see the cubes that I have here? Okay, now, last week, if you recall, we actually have water being displaced. So if let's say, for example, I remove this cube. Okay, when I remove this cube, okay, when displacement, when I remove, excuse me, when I remove the cubes, the water that is displaced will be equal to the water that is the volume of the cube. Okay, volume of cubes will be equal to the volume of water this place. Okay, if you put in the cube, but if you take it out, the change in the water level times the base area will give you the volume of the cube. Okay, volume of water change. Okay, that means if you remove the cube, okay, when you remove the cube, the volume of cubes is equal to change in height times the base area of the container. Okay, change in height times the base area of the container. So that's what we call by the displacement of the cubes, or when the cubes are removed or put in. Okay, now, so we have another volume question. So a typical volume question can be two types. So if I have a cube like this, a tank, okay, so this tank is completely filled with water. So how many cubes of size 3 cm each can it make? How many ice cubes? So you want to make ice cubes of 3 cm. First, you need to find the volume of ice cubes that you want to make. So in this case would be 27. Then you find the volume of tank, or volume of water in the tank, which is 20 times 12 times 15, to give me, anyone? To give me 3,600 cm cube. So to find the number of ice cubes, how do you find the number of ice cubes? In this case, if you want to pour the water and make ice cubes, how many can you make? So you take the total volume of water in the container, okay, divided by the volume of each ice cube. The volume of water in the container divided by the volume of each ice cube to give me how many ice cubes? Approximately, you can get 133 ice cubes. That is if you want to make ice cubes. But what happens if instead of making ice cubes, you want to fill the tank with 3 cm cubes? You want to fill it up. So this way, this method, you cannot find the volume of the container or volume of a tank divided by volume of a cube. But instead, you must find individual length where you can fit the cube. So that means you need to see length. How many cubes can you fill along the length? 20 divided by 3. Approximately, you can fill only 6. Breadth, how many can you fill? Will be 12 divided by 3, 4. And the height, how many can you fill? 15 divided by 3 to give me 5. So all in all, you can fill 6 times 4 times 5. What is the total cubes? Yes, total cubes to fit in will be 6 times 4 times 5 to give me 24 times 5, 120. See? Okay, so you must be clear when it comes to volume. They can ask you these two things. Or sometimes they tell you you have a block of wood. Okay, so let's say instead of a tank, they tell you this is a block of wood. And you want to cut 3 cm cubes from this block of wood. How many cubes can you get? So you cannot use this method of finding total volume divided by the number or divided by volume of the cube, but rather you have to use this method. Okay, all right. So these are the two types of volume question that is very common and familiar. Besides, of course, flow of water into the cube, which we will go through today. Okay, now let's continue with question 1. So a lot of you did question 1, and 2 of you actually got it wrong. So Perez not here, Cyrus is also not here. Okay, Perez and Cyrus. Okay. Yeah, I guess probably they're coming in, or they probably also have oral tomorrow. Okay, now, so you have A and B are two rectangular containers. Now, the base area of A, so base area of A is 450, and the base area of B has dimensions as shown below. So base area of B would be from here will be 60 times 30 to give me 1,800. Now, so you have tank A and tank B. If I multiply the base area, which is in cm squared, multiply by the height, which is in cm, I will get the volume, which is in cm cubed. Okay, now, so tank A base area is 450. Tank B base area is 1,800. Okay, now, tank A contained this amount of water and tank B was empty. Okay, now, so we want to find out what was the height of the water level in A. So to find the height of water level in A will be equal to, I take the volume of water divided by the base area to give me 45. Okay. Now, this is my answer to part A, 45. So for part B, Brandon poured some water from A into B without spilling. After that, the height of the water level of container A was the same as the height of container B. Now, so I drew this table here. It says here, Brandon poured from container A into container B. So the height of water level in A was the same. So the height, since it is the same, I'm going to label it as 1 unit. So if I multiply base times height, I will get 450 unit. Base times height will give me 1,800 unit. Since they have the same height. So how much water did Brandon pour into B? Now take note, the amount of water that is here did not change, right? Because the water is from A entering B. So which means that this total amount of water is the same before and after. So with that, if I take the base area times height for tank A and base area of B times height, will give me the volume. So the total volume that I have here is 2,250 unit. So which means that the volume here must be equal to the volume of the total volume of water that is in tank A. So from here, I can find what's the height. So in this case, the height will be 9 cm. So the height is 9 cm. How much water did Brandon pour into container B? So since the height we know is 9 cm, so this height is 9 cm. So volume poured into B will be, I take the base area times the height to give me 16,200 cm cube. Okay, 16,200 cm. Can you follow? Okay, now this table is quite useful. Okay, so it teaches you base area times height to give you volume. And because you need to make the height the same, like in this case, same as the water level of A was the same as the water level of B, so I make them the same. You can use X, no problem. You don't understand part B. Okay, do you understand that when I take base area times height will give me volume? Yashika? Do you understand?